Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So this is equilibrium of a particle, examples 56 to 58. A 1 kilogram ball bearing is pushed into the smooth right angle corner by the 20 Newton force shown, which passes through the center of the sphere. Determine the reaction forces exerted between the ball bearing and the vertical walls and horizontal floor. So here's the given figure. The ball is 1 kilogram times 9.81, so its weight is 9.81. And this 20 Newton force is this pushing force is directed down, to the left, and backward. So down at this angle here, 53.13 degrees, the vertical angle is 60 degrees. So for the solution, so we call the reaction at the floor as NF. So this is 9.81. Then at the left wall, NL, and at the rear wall, NR. So first we compute NF by summing up forces vertical equals 0. So the vertical component of the 20 Newton force, because this vertical angle is known, is simply 20 sine of 60 degrees. So NF equals 9.81 plus 20 sine of 60 degrees, the vertical component of 20 newtons. So NF equals 27.13 newtons. Now for the other reactions, the weight has nothing to do with this vertical with these reactions at the left wall and the rear wall, because it is vertical. Only this 20 Newton force will have effect on these normal reactions at the left and at the rear wall. But before that, we first compute the component of this 20 Newton force parallel to the floor, and that is 20 times cosine of 60 degrees. So it is pushing the ball uh, backward and leftward. Then after we compute the component of the 20 Newton force parallel to the floor, we multiply it further by sine of 53.13 degrees, this angle here, so that we can compute NL. So NL is equal to 20 cosine of 60 degrees, this component here, then multiply further by sine 53.13 degrees. So NL is equal to 8.00 newtons. Then for N at the rear wall, 20 cosine of 60, that's the force. Then we multiply it further by cosine 53.13 to compute NR. So that's the force, that component of the force that pushing the ball backward. So NR equals again 20 cosine of 60 parallel to the floor, then times cosine of 53.13 degrees. So N sub R is equal to 6.00 newtons. So that's the reaction at the rear wall. So this is just a matter of resolving a force into its components so that we can compute these reactions. For your part, a 200-pound traffic light is suspended 12 feet above the ground by cables from three 16-foot tall poles located as shown. Determine the tension in each cable. So here is a given figure. We have cables 1, 2, and 3. And you just sum up forces along X. You just decide which axis would you want to be you would want to be the x-axis, the y, and the z-axis. Then show that these are the answers. S1 256.4 pounds, S2 344.2 pounds, and S3 179.1 pounds. So that's it for your part. Problem 57. A 100 kilogram crate is supported on the smooth inclined plane by the cable and the horizontal force F tangent to the incline as shown. Determine the magnitude F and the tension in the cable. Neglect the crate's dimension. So here is the crate. It is supported by this cable and that force there that is parallel to this edge. And because it is inclined 36.87 degrees. So we have the weight and we have normal reaction. The normal reaction, since this is it is assumed that the incline is smooth, there's no friction, it's mentioned here. So the normal reaction is parallel to this plane. So it has no component in this direction here. So only vertical and in this direction, the normal reaction. And it makes 36.87 degrees also with the vertical. So for the free body diagram solution, so we have the weight of the crate 100 times 9.81, so 981 newtons. Then we have the normal reaction, which makes, as I said, 36.87 degrees with the vertical. And again, this normal reaction here, N1, is parallel to this plane here. So it has only components vertically and in this direction, or in this direction here, parallel to this. No component in this direction. And of course, we have the tension, which is complete. It is directed up, forward, and leftward. So since this distance is 4 and that is inclined, so we draw a triangle, right triangle. So this angle is also 36.87. So therefore, this vertical component is 4 sine 36.87, and this horizontal component of distance is 4 cosine of 36.87. So 4 sine of 36.87 is 2.4, and 4 cosine of 36.87 is 3.2. So therefore, S is directed leftward 3.2, forward 5 meters, then upward. Upward component of distance is not 2, it is 2.4 plus 2, so 4.4 all in all. So therefore, distance S is square root of 3.2 square plus 4.4 square plus 5 square, where 4.4 is this one, 2.4 plus 2. So our x-axis would be this axis here. Our y-axis is vertical, and our z-axis is this direction, forward or backward. So distance S is equal to 7.3892 meters. So first, summation forces along x equals 0. So S is directed leftward. Its force is S. So it is negative 3.2 component of distance divided by distance 7.3892. Then plus the x component, this component of N1, which is N1 sine of 36.87 equals 0. So F and 981 has no component along this axis or along this direction. So that's equation 1. Then summation forces Y, S times 4.4, this one, over distance, then plus N1 cosine of 36.87, the vertical component of N1, then equals 981, this one. Equation 2. Then finally, along this axis, the component of S is S times 5 over distance, then N1 has no component, 981 has no component, then minus F equals 0. So solving these two equations simultaneously, S is 836.4. We can solve equations 1 and 2 simultaneously. There are only two unknowns, S and N1. And N1 is equal to 603.7 newtons. Now to solve for F, we sum up forces along this direction. The component of S is, as I said, S times 5 over distance, then minus F equals 0. So 836.4 times 5 over distance 7.892 minus F equals 0. From there we can solve for F. F is 566.0 newtons. So that's it for this problem. And for your part, so that you can participate, A 10-pound block is supported by 3 springs as shown. The stiffnesses of the springs are K1 5 pounds per inch, K2 3 pounds per inch, K3 4 pounds per inch. Determine the unstretched length of each spring. So take note that the tension in each spring is stiffness times uh, change in displacement. The change in displacement is final length, which is the distance of each of the spring or the length of each spring minus the unstretched length, which is required here. So I suggest that there are only 3 unknowns tension in these springs, and you can set up 3 equations in 3 unknowns, then solve for the tensions. After you solve for the tensions, then tension is equal to stiffness times delta S, where delta S is final length in the spring in this configuration minus the unstretched length which is required. Then from there you can solve the unstretched length and show that these are the answers. LO1 is 47.23 inches. LO2 for spring number 2, 39.17 inches, and LO3. So this is K1, K2, K3. LO3 is 37.76 inches. So that's it for your part. Problem 58. The lines of action of 3 tensile forces concurrent at the origin O pass respectively through points A at -134 meters, B -323 meters, and C 4 meters. Together, they support a downward load of 900 newtons at the origin. Find the magnitude in newtons of each of the force to have a zero resultant force. So it means that summation forces x0, y0, and z0. So I will uh, represent each force into vector form. So take note that the starting point is the origin 0, and these are the terminal points. So therefore, for force 1 or S1, it is -1i plus 3j plus 4k over distance squared root of 1 squared, 3 squared plus 4 squared. So as simple as that. So the tension A is SA -1 plus 3j -I plus 3j plus 4k over square root of 1 square plus 3 square 10 plus 6 plus 4 square 16. So 10 plus 16 26, so square root of 26. I'm not showing it here, but I mentioned how to solve for square root of 26. Then SB is magnitude of SB, quantity -3i plus 2j plus 3k over square root of 3 square plus 2 square plus 3 square. 3 square plus 2 square, 9 plus 4 is 13 plus 9, so 22, so square root of 22 distance. SC is magnitude of tension C, S sub C, quantity 2i plus j minus 4k over square root of 2 square plus 1 square, 5 plus 16, 4 square 16, so 21, so square 21 distance. Then summation forces x equals 0, so we have negative SA over square root of 26, negative 3SB over square root of 22, positive 2SC over square root of 21 equals 0. So we have a downward load here supported, so let us say along y. So therefore, S summation forces y equals 0, SA times 3 over square root of 26, then plus SB times 2 over square root of 22, plus SC times 1 over square root of 21 equals 900, equation 2. And finally, summation forces along z equals 0, so we have SA times 4 over square root of 26 plus SB times 3 over square root of 22 plus SC times 2 times -4, -4 SC over square root of 21 equals 0. Then solving these 3 equations simultaneously, then we'll have SA 786.7 newtons, SB 482.4 newtons, and S sub C 1061 newtons. Now for your part, referring to the figure shown below and assuming unequal forces, F1 equals 500, F2 equals 400 newtons instead of equal forces. So F1 is up to the right and F2 is down to the right in the figure. Find the required tension S1 in the guy wire AC to prevent bending of the pole and the corresponding compression S2 in the pole. Be sure that the guy wire is placed in such a vertical plane as to eliminate bending of the pole. So I give you the hint, although it's not given in the original problem, so that you can analyze this and answer this. The resultant of the forces F1 and F2 must be coincident with the x-axis, and so that there will be no bending, so such that the x component of S1 and the x component of F1 and F2, which is coincident with the x-axis, the resultant will have zero component along x, so that there will be no bending here. So show that the answers are S1 1281 newtons and S2 1109 newtons. So that's it for your part.